Alright guys, today I'd like to go over problem 352 in this video. In this case we want to use mesh analysis to find I1, I2, and I3. So you want to find these current values in the circuit. Now again, specifically in this problem we're told to use mesh analysis, so that's how we're going to approach this problem. But before we move forward, we want to note that we have a super mesh here. So we have this super mesh here where we have a current source being shared by two different meshes. Okay, and that's the definition of a super mesh, which gives us an opportunity to simplify this circuit. Okay, so remember, a super mesh is when we have two meshes that have the same dependent or independent current source. Okay, so they share the independent or dependent current source. So two meshes that have same current source. Okay, and this could be independent or dependent. Okay, so in that case we can treat this in a different fashion. So what we can do is we can treat, so currently we have mesh I2 and mesh I3, so we can treat this all as one mesh like this. Okay, however we'll keep I2 at the top and I3 at the bottom. So how do we deal with that? I just keep that on the side for now. Let's go to mesh 1, which is the one on the left side, and just do straightforward mesh analysis. So I'm just going to say mesh 1. Okay, and I'm just going to go around the loop here. So first resistor I have up here is 2 ohms. So I got 2 ohms times I1, which is coming down the resistor here, but we also have I2 going up the resistor, so minus I2, plus coming down the branch here, we got 4 ohms down here, that's a 4 ohm resistor, again times I1, but down here we have I3 going up in the opposite direction, so we're just going to say minus I3. Okay, and then continuing around the loop here, we run into minus 12 volts, and then we set all that equal to 0. We can rearrange this equation. 3I1 minus I2 minus 2I3 equals 6. So we'll set this equation here aside. Okay, and now let's deal with the two meshes on the right, or specifically the super mesh. So let's just say we have the super mesh here where we combine mesh 2 and 3 together. Okay, so what that essentially means is we're going to ignore the green highlighted area, that 3 amps. We're going to ignore it for now, but we'll come back and compensate for it in a second using KCL. Okay, so if I go around this here, one big mesh, I'm going to have 2 for the 2 ohms up here. In this case I have I2 as it's going through the 2 ohms, but also I have I1 going the opposite direction, so minus I1 plus 8 ohms, we're going again clockwise, 8 ohms times I2 plus we have this dependent voltage source 2 V naught plus, going back up to the 4 ohms, it's going to be 4 times I3, and then the opposite direction we have I1 minus I1. Okay, this equals 0. We can rearrange this and simplify the equation. Okay. And then we plug this in here, we get, let me just write this here, I got V naught equals 2 times I1 minus I2. And we take, but the question is, where did we get V naught equals 2 times I1 minus I2? And we get that from here, because we're told that V naught is the voltage around across 2 ohms here. So if we look at this, V equals IR, so we're just using V equals IR, where our I is just I1 coming down, I2 going up, and then 2 ohms is our resistor. Okay, so that's a second equation, technically we can say. Okay, and then we can plug this back into the supermesh equation and then simplify, and what we'll get is minus I1 plus VI2 plus 2I3 equals 0. Okay, so again, let's repeat this. So using Ohm's law, we know that the voltage across the 2 ohm resistor is going to be this equation here, V naught equals 2 times I1 minus I2. We plug that back into this big supermesh equation, and we were able to simplify to get this third equation here. Okay, so we have this equation using the supermesh. However, the question is, well, how do we take into account this 3 amps that we just ignored? And the way we do that is we come back here and we do KCL. Let's choose this node here, and now we have a current coming in here, which we're going to say is 3 amps, and we have I2 coming in this way, and we have I3 coming out of it. So then we can define just what's input equals output. So we can say, based on this, is I3 is equal to the 2 currents going in, which is the 3 amps plus I2, and that gives us another equation we can use. So now we've brought that current source back into the full circuit, and then using these equations we can just substitute, and then we can solve for I1 individually, I2 and I3, and we find that I1 3.5 amps, I2 is minus 0.5 amps, and I3 is 2.5 amps. Okay, there we go. Okay, so what we're doing is we're looking at the circuit, looking for patterns. In this case, we saw a independent current source being shared by 2 meshes. So we said, okay, this is a super mesh. We can ignore it temporarily and treat this whole thing as one big mesh. Do the super mesh analysis, looking at the currents going around in circle. Do the same thing for mesh 1 here, and then we're given V naught across this resistance, which is going to allow us to get 2 V naught here, which will be substituted into that equation for the dependent voltage source. And then we'll go back, once we have these equations, we'll go back and we'll look at KCL at this node where we have 3 amps coming in, I2 coming in, and I3 coming out, which gives us this last equation. We substitute all these together into the equations, and we're able to solve for the problem statement, which is find I1, I2, and I3. Okay, we'll do another problem in the next video.